Now we have the initial verification of our attention-based processing data processing model for classification, and in the next we will use this classification model to build a decoder, which is one of the subfamily of the transformer family. We have discussed before that the the processing of the data is to look up in a dictionary and form sequence of vectors representing each of the token, and for each of the token we we do the attention based transform for several times until we have reached the same number of probability scores. So actually, to build, it is kind of a misnomer by saying we build a transformer from this classifier, because now we have already get the transformer. The only thing we need to do is to give the model use the model in an appropriate training scheme. So this model's behavior is adjusted in such a way that you give the model some former part of the training sequence. It intends to predict for each corresponding position the desired next part of the sequence. In the case of hello, we will form the pair of a training pair of data instance using this H to correspond to the E, because E will be the next character following H, and the E's corresponding target should be L, and so on and so forth. So in this way, we kind of move one character to the next in the sequence. Okay, it is like we have sliding window. Here, and we start from here. Let's see if the sequence is 4, and the training is this part, and the test is this part. If we have more characters, then we will have the next part of the training is just this, and the test will be here, including the space. By giving this kind of training pair to the model, we will adjust the model behavior so that given the former part of the sequence, it will tend to generate the second part. We call that decoder behavior, and if we use the decoder by giving it some context to begin with, it will start composing similar sequences that it is like that is like the sequences that it observed in the training compile of documents. So to do this, we need to by to do this, I mean when we have when we have using the dataset object to handle those training pairs and have already adjusted model parameters, but we want to use this mechanism to generate new data so that we can at least intuitively assess the model behavior. We give a sample function. Note this decorator, that means you do not need to compute the backpropagation in all the computation below. So this does not matter too much. This means to save some computation. And in here, we perform some given number of generation steps. For each of the generation step, we will use the first several characters, for first several tokens in the given sequence. Okay, and at the beginning we use whatever we have, but when we move on and have more and more characters generated, for example, if you are given maybe H and E, you have to start with the H and E. But when you have L generated for the next, you can use those HAL as input and let the model to predict what those are the next character for the HAL. So hopefully it will predict E for H. You just throw this away because this is not needed, and L for E, you throw this away, and another L for L. We keep this and attach this to at the last of the existing sequence, and in the next time we sample this for and generate do the other round of generation. Hopefully we get an O here, and we attach O to the sequence and we get HALLO. And this time, because it's longer than the maximum length of the sequence allowed, which is 4, so we take only the last 4 and do the generation again. Maybe hopefully this time at this location you have a space, and as before we just throw away all the generation from the previous locations. Okay, and do this so on and so forth until we have reached the given number of generation steps. This is what we have done. So this is to determine the input sequence to cut with the last maximum number of tokens in a sequence, the last so many tokens, and we use the model to predict the score. And there are some techniques such as those scores can be scaled to emphasize the difference between the scores, which when they are converted into probabilities, it becomes a winner takes all strategy. Alternatively, we can use a so-called high temperature, so that the difference between the scores after divided by the temperature is insignificant and gives the model a high variation. And we can also limit because the later part of the generation depends on the early part. If we have bad luck and take the unlikely candidate in the early step, you may end up with not very plausible sequence. So we can limit the generation process only to choose from the top k. The k can be chosen. If you give it a non-value, then this is not processed. If you give v3, then in each of the steps, it only choose from the top 3 possible characters. Of course, you can limit that to 1, which is in this case, you do not do sampling at all. You just take the most probable predicted sample. So this is a sample. Okay, let us use this our tiny GPT to do the sampling. Look, this is what we get. A, B, G, E, F, E. Okay, it isn't exactly the same as the A, B, C, D, E, F, G, E, D, C, B, A, M, this kind of sequence, but you get those consecutive English letters tends to be tied together in this example. So you can change those parameters and play with yourself, the code.